Welcome to Math 1508 Pre-Calculus for University of Texas El Paso. Go Miners. This corresponds to Larson's 10th edition of Pre-Calculus, Chapter 1, Functions and Their Graphs, Section 1.4, Functions. And this is Part 2 of the lectures for Section 1.4, specifically on domains and difference quotients. Now, the domain agreement. The domain of an algebraic function includes all real numbers except those that make the denominator 0, radicands of even index negative, or the argument of a logarithm non-positive. That's a mouthful. So what does it say? It says we could use any number, but we checked for denominators. Can't have zeros in the denominators. Radicands of even index, so square root, fourth root, 16th root, 734th root. You can't have a negative inside the radical, radicand, the inside of the radical. Or the argument, the inside of a logarithm, non-positive. So inside of a logarithm cannot be 0 or negative. Radicands, just not negative. All right? You can have 0 under a radical, you cannot have a 0 inside of a logarithm. Here we go with a couple of examples. So if we find the domain, g of x equals 1 minus 2x squared, I look for denominators, radicals, and logarithms. None of them appear, so the domain is all real numbers. Don't make it more complicated than that. Number 2, the function is s of y equals 3y over y plus 5. I don't want you to get hung up on x is domain, y is range. We could use any variable for anything. It's a variable. It varies. So when you have a function in terms of y, it's an input that we're looking at. We have a fraction. The denominator cannot be 0. So I literally solve y plus 5 is not equal to 0. And to solve a not equation, it's the same steps as solving for an equation. I'm going to subtract 5 from both sides. And this tells me that y cannot equal negative 5. Now remember, the domain is all real numbers except. So when we write it, make sure you put negative infinity to negative 5 using open parentheses so we exclude the negative 5, union with negative 5 to infinity. Last example, find the domain of f of x equals the square root of x plus 6 all over 6 plus x. Let's look at this in two parts. First of all, we know our denominator cannot be 0. So 6 plus x cannot be 0. Subtract 6 from both sides. X can't be negative 6. So we have to leave that one out because the denominator can't be 0. But we have a radical also. And the radicand, the expression under the radical, must be greater than or equal to 0. Right? It has to be non-negative. So we solve the inequality, x plus 6 is greater than or equal to 0. Subtract 6 from both sides and we find that x has to be greater than or equal to negative 6. Now from the radical, x has to be greater than or equal to negative 6. But from the denominator, x cannot equal negative 6. So we take away the or equal to symbol and x must be strictly greater than negative 6. And in interval notation, we would call that negative 6 to infinity. Parentheses, because we cannot equal negative 6. Also, we can never equal infinity, so that'll always have in parentheses. And least to greatest, so the negative 6 is smaller than infinity. Negative 6 goes to the left of infinity in our interval. The difference quotient. It's the basis for all of differential calculus. This is just the slope formula. It's just a fancy way of writing the slope formula for a pre-calculus student as opposed to what we would call slope for an algebra student. F of x plus h minus f of x all over h. As long as h is not 0, this is a difference, subtraction. Quotient, division. So difference quotient, literally saying a subtraction with a division. Another representation is f of t minus f of c, all divided by t minus c, as long as t is not equal to c, so we cannot have a 0 denominator in either case. And c is a particular value that we will be using. Let's take a look at one representation of each of these, more to be shown in class. Find the difference quotient and simplify. So f of x equals 5x minus x squared. And I want to find specifically f of 5 plus h minus f of 5 all over h. When I do this, I'm going to do it in steps. First I'm going to find f of 5 plus h. Then I'm going to find f of 5. And then I'm going to put it in this whole expression. So we take a look at one at a time. F of 5 plus h, evaluate the function, take out the x, replace it with parentheses, fill in the 5 plus h. So I'll have 5 times 5 plus h minus 5 plus h all squared. And when I square 5 plus h, I'll end up with 25 plus 10h minus h squared. Notice the use of parentheses because the negative sign is in front. It must distribute to everything. In the first part of this right side of the function, 5 times 5 is 25. 5 times h is 5h. Now I distribute the negative sign. 25 plus 5h, and then the minus 25 minus 10h, and a negative h squared. Combine like terms, 25 and negative 25 cancel out. 5h and a negative 10h gives me a negative 5h, and my negative h squared. So I've simplified this first term on its own, so I'm not getting lost inside a big fraction doing the simplification altogether. I'm also going to find the second piece, f of 5. So I substitute 5 in everywhere I see an x, and I use parentheses to make sure my operations still work out. 5 times 5 minus 5 squared is 25 minus 25, which is 0. I love working with zeros. Don't get used to it, because most examples don't have it, but when they do, take it and run. So here we have f of 5 plus h minus f of 5 all over h. I have my answer, negative 5 minus h squared, minus my second answer, 0, all over h. So I've put in f of 5 plus h, minus sign, f of 5. When I simplify, okay, I subtracted 0. There we go. In order to cancel this h from the denominator, I suggest you factor it out. Actually see it written as a product, because it's only through a product that you can cancel numerator to denominator. So negative 5h minus h squared, they have an h in common. I'm left with minus 5 minus h in parentheses. When my h's cancel, I'm left with negative 5 minus h. And for now, this is just practice of skill, some order of operations, manipulating expressions, equations, functions. We're going to have a very valuable use for this in calculus, however. Find the difference quotient and simplify. And this time, our function is f of t equals 1 over t minus 2. And we want to find f of t minus f of 1 over t minus 1. So this is given to us. We know our function, what it is that we're trying to find. Let's take it step by step. Now, first of all, f of t, that's right there. It's already there. No big deal. So let's find f of 1. F of 1 is 1 over 1 minus 2. Order of operations says take care of your denominator first. 1 minus 2 is negative 1. And now we can divide. 1 divided by negative 1 is negative 1. I could take a look at the entire rational expression, but I want to just look at this numerator first. F of t minus f of 1. That's 1 over t minus 2 minus negative 1, which becomes 1 over t minus 2 plus 1. But if I want to add a rational expression with an integer of 1, I'll need a common denominator. So I'm going to multiply 1 by the fraction t minus 2 over t minus 2, common denominator. Whatever we do to the numerator, we must also do to the denominator. So instead of 1 over t minus 2 plus 1, it's now 1 over t minus 2 plus t minus 2 over t minus 2. When we're adding fractions or rational expressions, our denominator stays the same. We add our numerators, 1 plus t minus 2, that's a t, and a negative 1. So t minus 1 over t minus 2 is our new numerator from the difference quotient given to us. So now if I want to find this whole thing, f of t minus f of 1 over t minus 1, I just found my numerator, t minus 1 over t minus 2, divided by t minus 1. But remember, dividing by any expression is the same as multiplying by its reciprocal. And when I multiply by 1 over t minus 1, my t minus 1's cancel out, and I'm left with 1 over t minus 2. Now, a couple of notes. Dividing by t minus 1, like I said, is the same as multiplying by its reciprocal. The second thing, funky example. Do not expect the original function back each time. That was just the random choice of 1 happened to work out that way in this particular example. It doesn't usually happen.